Welcome. Today I'm going to show you how to use the cast diagram to solve trigonometric problems. Well, more accurately, to find the additional angles that we need. Now, before we jump in with that, let's have a look at why we would need this in the first place. Why is there more than one possible answer when I'm looking at solving a trig identity? So, say I want to solve sine x equals 1/2, and that x is going to lie between 0 degrees and 360 degrees. Now, if you don't know this already and you put it into your calculator, you'd see that x was 30 degrees. But hopefully this is actually one that you will know the answer to. However, it's not the only answer that lies between 0 and 360 degrees. So if I sketch my sine graph between 0 and 360 degrees, I'll get this. Now, if I look at where it's going to equal 1/2, I'm looking at this point. And drawing a line across there, as I've just done, I can see that it's going to hit my graph in two places, here and here. Now, this first one is my 30 degrees. And this second one, you can see if this is a distance of 30 degrees from this point here, then this one's also going to be a distance of 30 degrees because they're symmetrical. Therefore, I know that this value will be 180 minus 30, which is 150 degrees. And obviously that is where you get your understanding from, and it's not very difficult. But as the problems get more challenging, then drawing countless graphs gets very time consuming, and that's one of the things we want to avoid in an exam. Let's just have a look at one just slightly more challenging problem in this way with a sketch. So I've got sine 3 theta equals 2/5, and I can work out that this initial 3 theta is going to be worth 23.6 degrees. And this would mean that theta is 7.9 degrees to one decimal place. Now, 2/5, just getting it on. So 2/5 is going to be something like that. And I can see that that's going to produce 6 different answers. And the gap for each of these answers is 7.9 degrees. And so on. And you can see that just drawing this one out would have taken a lot longer because I've got a 3 theta. And now just imagine if I've got a 3 theta plus 2 or a 4 theta minus 1. Those graphs are going to take a lot more thought to do, and the time that's going to take is just going to cost you in an exam. So drawing the graphs out or sketching them is a great way to start so that you can get your understanding. But the cast diagram is essentially your shortcut to be able to get in your answers. And that's what I'm going to show you now. So let's have a look at the cast diagram. So the first thing is I want a set of axes almost, x and a y, think of it that way. And then I'm going to label each of my quadrants like so. Okay, C-A-S-T, cast, easiest way to remember it. Now let's look at what they stand for. So C stands for cos, S stands for sine, T stands for tan, and A stands for all. What this means is that in this quadrant, first quadrant here, everything is positive. So sine, cos, and tan are all positive. In the second quadrant, sine is positive. In my third, tan is the only one that's positive, and in the fourth, only cos is positive. And in each one, we're always looking at the acute angle that we make with the 0 and 180 line. So I'm going to call each of these theta. And that's my initial setup. Now, I start at 0 degrees and I go anti-clockwise for positive angles. So you can see now this would be 90 degrees, 180, 270, and back round to 360. And when I need to, I can keep on going round and round in circles. This would be 450, 540, 630, 720, and so on. Now, these angles here and here are less important when I'm dealing with this. My angles on my horizontal line, these are the most important ones. Now, in each section, you can think of them as though the first section would just be essentially theta. In the second section will be 180 minus theta. And the third section would be 180 plus theta. And then we've got 360 minus theta. Then as I go round, in this first section again will be 360 plus theta. And then in the second section I'll end it with 540 minus theta, and then 540 plus theta, and then 720 minus theta. And I get these because starting at 0 to this angle is just 30 degrees. If I did that one, or theta degrees I should say. And then if I look at this angle, is going to be 180 minus 30. If I look at all the way around to this line, I've gone 180 degrees plus theta. And all the way around to this line, I've gone almost 360 degrees minus theta. And that's how it works, and I keep on going round and round in circles for as many degrees as I need, because sine, cos and tan, they all repeat their graphs. Now that I've shown you what it looks like, let's look at a series of questions where I'm using it. So sine theta equals a half, which we did at the beginning. First thing I can do is work out that first angle there, the one that I will get from my calculator if I didn't know it. And then it's a matter of a quick little sketch. So that 30 degrees is this acute angle here. Okay, now I know that this is positive. Sine theta equals a positive a half. Because it's positive, I want to look at the sections, the quadrants where sine is positive here, and sine is positive here. So it's positive in the all quadrant and the sine quadrant. Now, that's going to be 0 degrees, 180, and so on. So in this first quadrant, this is my angle there. So it's just 0 to 30 degrees. Okay, if I extended this, it's to here. So my first answer is this 30 degrees. When I look at my second answer, it's going from 0 round to this point, which means it's 180 degrees minus this small 30. So this one's going to be 180 minus 30. Which is going to give me 150 degrees. Now I'm going to switch to my black pen, and as I come round, we get back around to 360 degrees. Now if I carried on going, the next time I'm in this quadrant here is going to be 360 plus 30, which is going to give me 390 degrees. And then the next time I get round into this quadrant, I know that this is going to be at 540, so it's going to be 540 minus 30 degrees. Because in this quadrant now it will be this value minus the 30. and I can obviously keep on going around as many times as I want. Let's have another look at a very similar one. What about when sine theta equals negative a half? Now, if I put that into my calculator, I'll get negative 30 degrees, and that's not always going to be in the range that you want to deal with. And in the beginning, I'm just going to deal with the positive range. So I'm going to set this up. 30 degrees is still that acute angle there. And personally, when I'm doing these kind of angles, I just ignore the minus, do it in positive first so I can work out this angle. But we'll talk a little bit more about that as we go through it. Now, as we were looking, sine theta is negative a half, so it's a negative. So sine is negative in the sections where it's not positive, so it'll be in T and C, so in these two quadrants. So in this quadrant, it's going to be 180 plus 30. And in this third quadrant here, fourth quadrant, is going to be 360 minus 30, so 330 degrees. And if you put those in your calculator, sine 210 or sine 330, and press equals, your calculator will return you negative a half. And again, I can keep on going, 540 plus 30, and then 720 minus 30. Hopefully now you're started to understand it. I'm going to do a few more straightforward ones like this, and then after that, then I'm going to do some more difficult ones. So if you are fine up to this point, you can skip the next little bit and then catch back up in a few moments. So let's look at finding this one. Cos theta equals 1/3. So using my calculator, theta is 70.5 degrees. And then I go to my cast diagram. And sorry, I'm going to do these between 360 and 0, just to give us some limits. And this acute angle is 70.5 degrees, and that is the same for all of these acute angles. Now, obviously, once you get used to this, you wouldn't write this in for all of them. It's just there to help you. So we got 0, positive direction, round to 180, back round to 360, and so on. So looking at this, I've got cos theta equals 1/3. It's positive. Cos is positive in the section where all of them are positive, and in its own quadrant where just it is positive. So we've already got the first answer, 70.5, and then when I look at the second answer, that's going to be 360 minus that 70.5, because it's in this fourth quadrant, which is 360 minus theta, to get to this line. So that will give me, for my set of angles, 70.5 and 289.5. And it's definitely worth keeping the full answer in your calculator, not rounding too soon, because if I wanted to do this to 3 significant figures, this answer would actually be 289, not 290, because the actual answer is 289.47. So you need to make sure that you're always going to keep your full answer in your calculator and not round until the end of the question. So let's have a look at this one. Now, if I put this into my calculator will return 101.5 degrees. Now, when I come to my cast diagram, that does not mean that this is 101.5 degrees, because that does not make any sense. Cannot be between 0 and 90. So that's not the 101. The 101 is referring to this whole angle here. So there's two ways I can get the acute angle. I can do 180 minus that value, which is 78.5. Alternatively, and I'll put this in black, I can look at working out cos theta equals just 1/5, as in keeping it positive, and that will return me the 78.5, the acute angle. Okay, and that's the way I prefer to do it. So I put it in as if it's positive first to get the acute angle, and then I look at my sections. So cos is negative here and here. So my two answers are, in this section it's 180 minus 78.5, which is my 101.5. And in this section here is going to be 180 plus 78.5, which is 258.5 degrees. And again, between 0 and 360, those would be my two answers. A negative cos, like here, is the only one that's going to throw up that awkward number for your acute angle. The sine and the tan, they won't. Now, what happens if I don't have just a single angle like theta, and I have something a bit more complex like 2 theta, 3 theta, 2 theta plus 30, 3 theta minus 40, or something like that? So here we have sine 2 theta plus 20 degrees equals root 3 over 2. And I'm solving this where theta is between 0 and 360 degrees. Now, the safest way to approach this type of question is to give yourself a different letter, like x or y, and make it equal to the value inside the bracket, so the angle. So let x equal 2 theta plus 20. Now I have sine x equals root 3 over 2. But to do this, I've also got to adjust my domain. So change in theta. So first of all, change it into 2 theta to go with my what's in my bracket. So that's going to be 7, 20, and 0 degrees. And then I'm going to add 20 to it. And then this is now my range of x. So I want to find the acute angle. So I'm just always going to use this positive root 3 over 2, inverse sine of that, and that will give me 60 degrees. Okay, I've purposely picked a nice angle to do this one with for the demonstration. So all of these are 60 degrees, as we've talked about before. Okay, sine is positive in the all section and the sine section. And I'm starting at 0 and I'm going in this direction. Okay, so 0 to 180, back round to 360, and then I'm going to continue round to then get to 540, round to 720, and then I have to go a little bit further. So let's look at what's happening. So starting at 0, going around here, the first angle I get is 60 degrees. And obviously my lowest range is 20, so that's fine. Carry on going to here. So this is now 180 minus 60, which is 120 degrees. And then continuing around, we don't want anything in these sections to here. So now we're up to 360 plus 60. So 360 plus 60 is 420. And then keep going to 540 minus 60 is then 480. and then keep going. We don't want anything in these sections, and then we want to go 720, and then another 20 degrees to 740 is not enough to hit this angle, so we can stop there. Now these are my answers for x, but we know that x actually equals 2 theta plus 20 degrees. So this is what equals each of these angles. So for each of them I need to take 20 degrees off and then divide by 2. So if I think about taking the 20 degrees off, so my 2 theta would equal 40 degrees, 100 degrees, 400 degrees and 460. And then dividing by 2 gives me 20 degrees, 50 degrees, 200 degrees and 230 degrees. And these are all my solutions, and as you can see they all appear within my original limits of 0 and 360. So here we have tan 3 theta minus 40 degrees, equals 2, and this is between 0 and 180. So this time I'm going to go a bit quicker. So I'm going to say let x equal 3 theta minus 40. So tan x equals 2. And changing my domain here, times in by 3 first, and then taking away 40 degrees. So my x range is between 500 and minus 40. So working this out, x gives me 63.4 degrees. And then if I go to my cast method, that's the angle in each section. Tan is positive here and here, and starting at 0, going in the positive direction, we get around to 180 to 360, and then back around towards that 540. So my first angle is the 63.4, then my second angle is 180 plus 63.4, which is 243.4 degrees. And then following that back round, we get to 360 plus 63.4, which is 423.4 degrees. And then carrying it back around. Now, when we hit here is 540, we only want to go as far as 500, so there isn't an additional angle there. So now you can see that my x equals 63.4, 243.4 and 423.4 degrees. And as we said before, x is 3 theta minus 40. So that is what all these angles essentially equal. So I need to add 40 to them and then divide by 3. Now obviously I'm doing these in extra steps there, so hopefully it's easier to follow, but you can do these in kind of one go if you want. So you've added 40 to each angle, now I need to divide each angle by 3. And here we have our 3 answers. Now let's try a few yourself. Now I can also use the cast diagram if I want to look at negative angles. I just need to go in a clockwise direction. For example, so here we have cos theta equals a quarter, but this time you'll notice my angles between negative 360 and 0. So first I'll find out what the acute angle is. So I'm just going to put a quarter inverse cos of a quarter, I should say, into my calculator, and I'm going to get 75.5. So that angle there, 75.5. That acute angle I can always get by using the positive values. Even if I had a negative one here, I use the positive one to get this acute angle quickly. Now to go in the negative angle direction, we go in the opposite direction, so we go in clockwise. So this would then take me to minus 90, minus 180, minus 270, and then back round to minus 360 there. So we're going in this direction as we go round. Now cos is positive in this section and this section. So looking at this, I've got, and each of my angles, as we remember, are 75.5 in this case. So going in this direction, we've got 0 minus this angle, so minus 75.5. So negative 75.5. If I keep on going round, I'm almost at negative 360. So I'm negative 360 plus 75.5. So negative 360 plus 75.5. And you can always check which way round it is just by, am I adding or subtracting? Well, if you subtracted 75.5 to the minus 360, it's going to put you in this section, not in this section. So this is minus 284.5. So my angles here of theta are minus 75.5 and minus 284.5. Okay, so if you want to go in any negative angles, and some questions you might have to do positive and negative, then all you're doing is you're going in a clockwise direction instead, but using the cast diagram in the same way. The only difference is obviously you've got minus 90, minus 180, minus 270 and so on instead of the positive angles. Hopefully you found this video of use. Please comment below any questions you may have, anything you want to see a bit more of. If it wasn't clear enough and you want me to do another one, I do think, explaining the cast diagram and how to use it is very difficult on a video compared to being in person. So hopefully you've got enough out of this, but if you want more, please let me know. Again, as always, if you've enjoyed the video, hit a like. If you haven't subscribed, please subscribe to my channel.